Look at transforming quadratics. And when they're talking about transforming or graphing a quadratic, the easiest form to graph in is called the vertex form. And we'll kind of talk about why after. But this is your original, or they sometimes call it parent function. We always have y and x. All equations are a relationship between y and x. But we have some other letters, a, h, and k. And they tell us where on a graph to start drawing the quadratic, and then exactly how to draw the quadratic. Okay, so depending what number is in for k, okay, k represents vertical movements. So if you have your original quadratic, if k is a positive value, like positive 2, that means the whole quadratic is moved up 2. If it's a negative value, it goes down. So the whole quadratic will have moved downwards. Okay. H is horizontal movements. If the quadratic, say that's the original, is a negative value, it actually goes in a positive direction, so it moves to the right. Okay, so that's if it's a negative value. And if this is a positive value, it actually moves to the left. And then A is a vertical stretch. So when they talk about vertical, that means it gets pulled from the top and the bottom. Think of it like an elastic band being pulled, so it kind of comes inwards. And if the absolute value of A is between 0 and 1, the original parabola, that's the original, it gets much wider. Think of it like it's being crushed from the top and the bottom like an elastic band. So that's what they mean by compression. And finally, if A is negative, let's go down here. You have your original. If it's negative, it's just flipped. It goes the other way, so it opens downwards instead of upwards. Okay. They also call this vertex form because whatever number is in for k, that's the y value of the vertex. And whatever number is in for h, the opposite sign of it is the x value of the vertex. So if we have positive 2 in here, that means the x value of the vertex is negative 2. Okay, lots to remember there. But what we're going to do is we're going to experiment with this. So whenever they talk about a translation of some number, they're talking about from this parabola here. Okay, and I'm going to write some key points actually on the parabola. 0, 0, that's the vertex of the original parabola. Okay, it's at the origin. Another key point is 1, 1. No, not 1, 2, 1, 1. That's a key point. Another one is negative 1 and 1. Okay, so these are all key values on the original parabola. We'll do a couple more. And the way you would technically get these is if you move to the right one, you square it. So 1 squared is 1, so that's how high we go up. Negative 1 squared is positive 1, so that's how high we go up. So that's a way you can kind of find those values. 2, if we move 2 to the right and square it, 2 squared is 4. So another coordinate is 2, 4. And it's symmetrical. Okay, so there's like, think of this as called the axis of symmetry. It's symmetrical on both sides. So at negative 2, the y value would also be 4. We could probably squeeze one more in there. 3 squared would be 9, so that's another coordinate on the original. And then negative 3 squared would also be 9. So there's another coordinate. So these are all the original. This is what we're talking about. Movements from the parabola that has these key points to it. Okay. So here's our vertex form. Right now my h value is 0. Okay, so like we said, that's the x value of the vertex. It's 0. And the k value is 0. So that's the y value of the vertex. If I move the k, so I'm going to push play and this value is going to change. You're going to see that the parabola continuously moves up. See if I can catch it as you can watch the value of it drop. Okay, so the k value is always affecting the y value of the vertex. So as it goes negative, it goes downwards. Oh, can we catch where it goes? Oh, I can't quite see it all. Okay, but as it comes up, it goes upwards. So that's what it does. It just shifts the whole thing. The way it's drawn is the exact same each time, but it just shifts it up and down depending on what other value you put in for there. So k moves it up and down. Let's go back to 0, so we start at the middle again. All right. The h value. Now this one's a little confusing. Okay. The h value, it moves it left and right. Okay. So get over the 10. Great. The only difference here is, actually I'll let it go, and you'll see it moves it left and right, just keeping the y-intercept. So anytime you affect this h value here, you're moving the parabola left or right. There's no real difference. But here's the key here. Okay, h is negative 2.5. But if I were to plug this in here, that would say x minus negative 2.5. Okay?
Makes it positive.
Makes it positive, exactly. So that same parabola, I'm going to draw it out here, y equals x plus 2.5 squared. And there it is, okay? So it changes the sign inside here is always the opposite of what you think would happen. When k was positive, everything went up and down. We already saw that. Oops, let's push play. It goes down if it's negative. It goes up if it's positive. That makes sense. That's very intuitive. For the h, it's a little opposite. Though here it looks like that. When we were to go over to positive 2.5 or 2.4, if I plug that in, it would say x minus 2.4. So it kind of does the opposite of what you think would happen. Okay, so keep that in mind. So those are called horizontal translations. The first one's called vertical translations. Running out of space on the disk here. Okay, and then finally, let's put that back to 0. A. Okay, the first thing I'm going to show you is if A is a negative, it just flips it. Okay, so it's now been flipped. It's identical. Think of it like it's a mirror image, a reflection on that x-axis there. Okay, but not only does the being negative or positive matter, but the absolute value of it matters. So as the value gets higher, you can see that it stretches and gets thinner and thinner and thinner. And as the value comes down, it gets wider. 1, oh, I almost caught it. 1 is our original, so that's why we're always in reference to 1. Anything greater than 1 gets thinner. Anything between 1 and 0 gets much wider. 0 doesn't exist. And then at the negative values, between 0 and 1 is wide. 1 is our original. And then anything greater than 1 is much thinner than when it looked before. Okay, so those are how the A movements of the vertex form or of a quadratic look. And you can kind of play them all at the same time and really cool stuff starts to happen. Whoa, amazing. Okay, but that's it. That's what transforming a quadratic kind of around a page it does. Okay. One other way you could draw these is these 5 coordinates. You can just kind of know where they are, but wherever the vertex is, okay, assuming the A value is 1, to draw the original one, you go over 1, up 1. That's what's happening there. You've gone up 1. Then you go over 1 more, and then you go up 3. So you keep going up by the next odd number. You go over 1, we go up 5. 4 plus 5 is 9. After 5 would be 7. So you'd go over 1, and then you go up 7 units, which would be right there. 7 plus 9 is 16. So that would be the next major point to draw. So you just kind of go up by odd numbers. But that's only if the A value is 1. If the A value is another one, it gets a little more complicated how to draw that. You kind of have to go over 1, up 1 times whatever the A value is. So let's say A is 2. You'll notice everything gets much thinner. So you go over 1, up 2, because 1 times 2 is 2. Over 1 more, instead of going up 3, multiply that 2, you go up 6. So it gets a little more complicated, that skipping rule. Okay? But that's for the original one, that little skipping rule there.